Do you like engineering? Well, if you're watching this channel, the answer is probably yes. What is it like to work as an engineer in the industry, working on projects that have real-world impact in people's lives? This past summer of 2021, I had the privilege of working with Ford as an intern with their metals manufacturing team, and I got to meet so many remarkable people while I was there. One of those people was my manager, Mr. George Luckey. He's worked his entire career at Ford, and he's had his hands in a lot of very important and influential projects, one of them being the aluminum F-150. So I figured there's no better way to tell you guys what it's like to work as an engineer on real-world projects than to get you guys an interview with George. So if you want to hear about George's experience with working in Ford, as well as his thoughts on the automotive industry and his advice for young aspiring engineers, you better stick around and watch the whole video. Good morning, George. Thank you so much for joining me today. How are you doing?
Morning, Kyle. I'm doing great. It's good to be here with you.
Awesome. And it's great to have you talking to the Builder Dude 35 community today. They're all very excited to hear about your experience with Ford.
I'm really excited to be here. This is a lot of fun.
Cool. So could you just introduce what it is you do at Ford for the folks at home?
Yeah, I am a engineer in Ford Research and Advanced Engineering in Dearborn. I work in manufacturing research, specifically in additive manufacturing metals, as well as sheet metal forming.
Awesome. Thank you very much. And could you tell us a little bit about your educational background?
Yeah. So I have a Bachelor's of Science and Master's of Science in Mechanical Engineering from the University of Tulsa. And I have a PhD from Michigan Technological University. And I actually got my PhD while working full-time at Ford.
Awesome. Thank you for sharing. So a lot of the viewers on my channel are younger, maybe middle school age, but are interested in pursuing engineering. And they might be wondering, at what point did you realize engineering was the career you wanted to pursue?
As far back as I can remember, definitely elementary school, I remember really liking science. I thought it was awesome. I talked about it all the time, to the annoyance of probably my parents and a lot of folks. My dad is retired, but he had a career as a machinist, and he worked with a lot of engineers, and he brought me in one day to his job to talk to one of the engineers that he worked with. And I had a great conversation, and after that, I was sometime in high school. I knew that was it. That was the way for me.
Awesome. And what was your first job after you graduated from university?
My first job was in 2000 at Ford as a Ford college graduate as a research engineer at Ford.
So have you been working your entire career with Ford since graduating?
I have.
Awesome. And just another quick question for people to get to know you. What are some hobbies you like to enjoy in your free time?
Free time is limited between family and job. But I do have one good hobby that I try to keep up with. I am a very amateur guitarist and songwriter, and I have a small band. We haven't really been able to play anywhere because of the pandemic. We don't play that often, but we do like to record. We do practice. It is a blast.
You mentioned that you had started working Ford straight out of university. What inspired you to work for Ford, and at what point did you decide that that was the career path you wanted to take out of university?
So before I graduated, I had a few internships as a bachelor student, and a lot of them were in the petroleum related industries because of where I grew up. Really good jobs. I enjoyed them. I learned a lot. I had an opportunity in the summer of 1998 to come be a summer intern, not unlike you, and it was in research engineering, specifically in composites research. And I loved it. I was hooked. After that, I knew what I wanted to be, and that was a research engineer at Ford. And so I was going back to get my master's. It was in automotive related. It was an automotive related thesis, and I told anybody who would listen that I wanted to work in automotive. So that was how it happened. Yeah.
So over the years of working with Ford, I'm sure your role has evolved. Could you tell us about your role today and how it is different from your role when you first started?
Well, I started as a research engineer, working in sheet metal forming. That was my job originally. It was on lightweight aluminum mostly, and looking at elevated temperature forming processes. It was very, I wouldn't say pie in the sky, but it was for niche vehicles like technologies being used at Aston Martin and Ford GT, the one that we made in 2003 era. So these really supercars. That evolved as Ford started looking at opportunities to use lightweight materials in higher and higher vehicles. I started working on technologies for higher and higher vehicles, which was awesome. It was a lot of fun. And that evolved to being what we call a technical specialist. So it's a subject matter expert, sort of a subject matter expert role at Ford. It's very focused on specific technologies. Mine was stamping, sheet metal forming, stamping, and sheet metal alloys. Now, fast forward, I am now manager of its additive manufacturing of metals, stamping, and sheet alloy development. So part of it, stamping and alloy development, I've been in since I started at Ford. The additive is brand new, and as you know, we have a great team here that is really motivated and loves what they're doing, and I'm really excited about it. So that management role is a pretty recent thing.
That's so cool that you had some involvement with the Ford GT. I was very young when that car came out, but I mean, as you know, I'm a huge car fanatic. I've been playing car video games for as long as I've been a sentient being, basically. And the Ford GT was always one of those super cool cars. And I would just love to own one someday. They're very expensive, but for a good reason.
I had a very, very small bit to play. A lot of my colleagues had a big role to play in it. I got to observe them and how they interacted with the program team. That was a lot of fun. And the coolest thing that came out of that was I actually got to drive one of the prototype builds, and it was a wicked car. But as I've evolved and transitioned at Ford, my involvement in programs has become much, much more. And that's watching my early colleagues and see how they did it. It's what I aspired to do, and that's what I do today. I really enjoy it.
That's great. So you mentioned that your role is primarily focused on management. I know that a lot of young people watching, and I'm honestly myself included, even a lot of people here at MIT are wondering about the relationship between management and engineering and industry. Some people might consider maybe going into product management. Some people might want to continue specializing in a technical field. Could you tell us about what was it like making the decision to transition into management and what motivated that decision?
Well, I have a really interesting situation, a fortunate situation at Ford in that I'm at research and advanced engineering. So the managers at research and advanced engineering all the way to our vice president and chief technical officer are engineers. They're all technical people. They have lived it in automotive, and they have just a depth of experience. My boss actually got promoted. It was around 2013 or 2014. And I started to transition from being solely technical implementation person, a person who develops technology and brings it into the product lines, to starting to also supervise other people who are doing the exact same thing, but on their focused area. And in those situations, your job is to help knock down barriers, to help them get the resources they need, and to help connect them in within the company. It's a big company, it's a large network, and sometimes you need help to know who to talk to about how to move to the next step. And so as I started doing that, I actually started enjoying it, because early on, if I had done that in 2000, I would have been a disaster, because I didn't know the company, I didn't know the processes, I didn't know the people, I didn't have the relationships, and I certainly didn't know enough about how to make a car. I'm still learning how to make a car. There are many people, many people at Ford who are way more knowledgeable than I am. But in my area, I am able to help my team sort of navigate and figure out what the right solutions are and coach them on, just good practices. So.
In years past, I've heard that you had some experience working on the aluminum F-150. I'm just curious about learning more about your role on the project, and could you tell us what it was like working on the project? Or first, you should actually tell the viewers at home about the aluminum F-150 for people who might not be familiar with it.
Yeah, no problem. In 2014, starting in 2014, we launched the 2015 F-150, which was a changeover of a primarily steel body structure to a primarily aluminum body structure. that still has a steel frame. The vehicle has similar powertrains as before. But what we did is by going to the lightweight, high strength body construction, we enabled best in class fuel efficiency while enabling best in class tow and payload capability. So that was the engineering trade-off in play there, because we wanted to keep making the best trucks that we've ever made. So you just continue one-upping yourself with every generation. So that was the path we saw that was best for us to do. And my role, I am a member of a core team of folks from our product development people. Those are the people who actually design the vehicles, both shape them and engineer them. Vehicle operations, this is manufacturing engineers, plant engineers, and UAW members are also on this team. Materials engineers, quality engineers, purchasing folks, buyers, and other colleagues from Ford Research, both in the United States and Germany, in other areas, whether it be welding or paint, or safety analysis. And then we in turn worked with these really fantastic sheet makers to come up with the alloys, the metallurgists at those sheet makers to come up with the materials and the alloys that we could make enough of it in volume to make F-Series, which is a tremendous increase in volume for the aluminum industry in the United States. So we really, I think altogether, we really changed and reshaped the aluminum business here in the U.S. It was pretty incredible. My primary role is we did a lot of material development, a lot of material selection. So picking what materials, where to use them, how to use them, and then working with the rest of the company to figure out how to put it all together. And in our lab, we did a lot of lab testing for mechanical properties, chemical analysis, metallography, heat treatment, a lot of what you do in your first 2 years of college, just redoing that over and over and over again. So don't forget that stuff, it's really important. Round robin testing, so with suppliers to make sure that we're all testing the same way, that we're all getting the same result and all talking the same language. And we write a lot of papers. We developed and published different test methods to make sure that our teams in the plants, they do something a certain way. Well, the people who make the metal, they may do it a different way in the way they test it. We have to align that. So we came up with new tests to make sure that they were all talking the same language, so that the sheet metal would be made in a way that they could test it, and then when we went to the plant, it would work just great. And so that was really important. And I think, what was it like to work on a project like that? It was, vehicle engineering is always fun to participate in. It's always exciting, especially when you see that vehicle going down the road. Vehicle launches are intense, exciting, and challenging. So taking that and then starting it in the plant is one of the most intense things that you do in our career. In fact, I mentioned earlier, when you hire into Ford, very often it's a Ford college graduate. One of your rotations is to go out to the plant to launch a car, because it's what we do. It's what we do really well. It's really hard. It's one of the most important functions we have. And there was, I had this great moment where I was my first drive in the 2015 F-150 was actually I had gotten a loaner for the weekend from the company. I took it out. I went to a sod farm. I filled it up with sod. I brought it back and I resodded my whole backyard. And it was this great accomplishment because doing that with my truck, that was just the best. So.
Yeah, that's amazing, because this is a vehicle that you've developed yourself, and now you finally get to put it through its paces and see if it lives up to all of the expectations that you've held when you were designing it.
I gotta say, it felt good. It felt great. So.
And I mean, many of my viewers at home are interested in engineering and builds robots in particular, and I'm sure they can share in the joy, in the sense of euphoria when it finally pays off. That thing you've been working very hard on is finally. And
that euphoria comes from a lot of failure. So a lot of things not working the first time, and then when you put the final product out, it works. It's great.
Yeah, and it reminds me of that Edison quote that's like, I didn't figure out how to make a light bulb. I only found 100 or whatever the number is ways not to make a light bulb.
Right. That's right. Absolutely.
You listed a lot of the advantages to switching to aluminum and improving the performance of the truck. But a lot of engineers are always faced with trade-offs. So I was wondering, were there any disadvantages to switching to aluminum? And in particular, were there any people who are skeptical of the switch to aluminum? And how did you convince them that this was the right way to go?
Oh yeah, any major switch, there's going to be skepticism, but we convinced with data, both inside the company and outside the company, both in performance and our ability to make one truck a minute rolling down our assembly line. The biggest challenge was to establish, well, at least the biggest challenge I worked on was to establish the capacity to make that much automotive sheet aluminum in North America. I think it was about a 50x increase in capacity when it's all been said and done. And it was big. It was a big shift in the industry. And so, yeah, definitely there were folks who disagreed. But in the end, we've maintained a best-selling truck. We've maintained customers having their needs fulfilled, and we continue to one-up ourselves with new capabilities. And so it's been a platform that enabled that.
Thank you. And I was just curious, what is your proudest contribution to a Ford project during your entire time with the company?
Well, it's going to be boring maybe to a lot of your viewers, but maybe not to you because you're a material science major. So you'll get this, I think. And I think a lot of people will too. It is, I was on a team, and it's a big team effort. You got to remember that. No one person gets all the credit. I was on a team and just a member of it that drafted, released, and implemented new aluminum sheet metal and extrusion material specifications. So, and laboratory test methods. And those are what we use to specify what kind of material we use and buy. And now those are used actually around the world. And, to see trucks coming off the line at around 1 a minute, using the metal that we engineered, and then to see that same metal being in Europe or being in China and really going around the world and getting that mass efficiency of scale is just great. So
I want to follow back on something you mentioned. Your assembly line produces around 1 new F-Series truck per minute. Mm-hmm. That's an incredible proof.
Oh yeah, it does. At 3 different plants. Yeah.
That's just an amazing kind of like mind-boggling statistic.
They actually challenge each other on who can get more out. Yeah, great.
I'm sure Henry Ford would be really proud to see where his company has come in the last 110 some odd years.
I think Henry would say we're still not good enough.
That's true, because he was, from what I understand of Henry Ford, he was somebody who is very focused on optimization, which is what led to his success with the Model T and all vehicles afterwards, and kind of cemented Ford's place in the market. So yeah, maybe you're right that maybe he would do a very thorough audit of the Ford manufacturing, saying, I think you have room for improvement.
We'd be lucky if we got a nod of the head, but absolutely it would be worth it. So.
What was the most difficult decision of your career?
My most difficult decision was making the leap to move to Michigan and take the job at Ford. I grew up about 1,000 miles away from here in a small rural community, and I went to school in Tulsa. So I lived in a city, but not a city the size of Detroit. Great city, but not quite this big. Definitely a little slower paced. Completely different area, and it was different. But I look back and it was a hard decision, but it's one I'm really, really happy I made.
In the technology world, moving for an opportunity like you did is often very commonplace. And I know in my audience, there's a lot of international viewers who may even be moving across countries or across oceans to pursue an opportunity. So I'm wondering, for the folks back at home, could you tell them more about your thought process of deciding to move to Michigan? In particular, how did you convince yourself that this was the right decision for you in your career?
I think, well, one was just the sort of the somewhat awestruck thing of working for a brand that's recognized around the world. There's something to that. I can't quite explain it, but there's something very cool, and it's one of the most recognized brands out there. And being a part of that is great. Being able to get access to the resources and the interest of a company like that wants to participate in the kind of work you're doing to advance automotive technology, which is what Ford is and does, was just something I couldn't pass up. The ability to make an impact on vehicles has been something I, as a kid, didn't dream of, but as an adult, I realize is special even at that. Not everyone gets to do it, and it's pretty awesome. So I'd say if you get the chance to work for an automaker and have an impact on the future vehicles and where the auto industry is headed, you should really seriously think about it. It's a good ride.
I really appreciate you sharing your thoughts on that. Thank you. And I'm sure it's going to be helpful for a lot of my viewers. Where do you see your career taking yourself in the next 10 years?
Well, I mean, I would really like to stay in Ford research. I love it. It was my dream job when I came here. It's still my dream job. I think in 10 years, the experience I'm going to have is a lot more about manufacturing of electrified vehicles, a lot more research and work and implementation on topics of sustainability. And as always, there's just the culture of continuous improvement in advanced manufacturing and implementing those technologies to continue to get better. I think that's where I'm headed. I look forward to that.
Thanks, George. We've heard a lot about your career, and now I'm interested in pivoting towards your thoughts on the automotive industry. So to kick it off, I want to ask you, what is your favorite Ford vehicle? And this could be from any era of Ford.
It's a 2017 Ford Mustang GT 5.0, a black. So I had a lease car just for a summer. Ford had this special deal, it's a summer lease. I wish it was a year lease now. So I had that car and I loved it. I love driving it every day. And I missed that car actually every day since I turned it in 2017. It was the best. So I still want that thing back. Mustang is my favorite Ford car.
As a fellow Mustang fan, I'm very pleased with your answer. As you know, I've mentioned it in some of my presentations. I've had a 98 Mustang GT that's been in my family since technically before I was born. That was my dad's car, and I always grew up admiring that car. I like to think it was my first inspiration at becoming a car person. And I remember as soon as I turned 16, which is the minimum age you're allowed to drive in New York, I begged my dad, please teach me how to drive this, and had the 5-speed manual. And it was so cool just getting to learn that car. And yeah, Mustangs are just such great vehicles, and they mean a lot to a lot of different people.
They do. My dad actually has a 65 Mustang he's rebuilding, and it's a slow process, but a really pretty car. And so, they really, they just stand the test of time. It's pretty cool.
In your eyes, what does Ford do differently or better than other automotive OEMs? In particular, people might be thinking of General Motors, Toyota, Volkswagen, etc.
Well, I want to be careful about saying better. I can say maybe different, and different is my perception of those other OEMs. I have a lot of colleagues and friends at the other OEMs, and I don't want to disparage anybody. They're great companies. But I can talk a little bit about Ford culture. It is a big company, and it's funny, but if you see someone at an airport and you say you work at Ford, and they say, "Oh, do you know my cousin?" as if we would know them. But it's kind of weird, but actually sometimes I do know them. And even though it's a big company, it does have this extended family feel. It's a very competitive team environment. And working here tends to instill some camaraderie and loyalty. I don't know if it's at other companies. I haven't really worked any other companies, but I know it's here. And I know that current, former, retired employees have a sense of it, and it's generically referred to as being part of the Ford family. Maybe because we have such the Ford family, the Ford family has a very big part of leading this company. And I think we all it cascades down to us as a sense of ownership of this place as well. And I can just say it's a club I'm very, very proud to be a part of. Now, on the Ford product side, we are good at putting technology into as many cars as possible to benefit as many of our customers as we can. That is what excites me. And that's what I know a lot of us really enjoy. And there is an ad back from the 1920s, which kind of harkens back to this. It stated that opening the highways to all mankind. And it's funny, but I think that mentality still exists with us. So it's something that's carried through, and I think it's here today.
So I heard you use this phrase Ford family, and indeed during my own time at Ford this summer, Ford family was a phrase that I heard a lot. And from what I understand, it actually has a literal meaning as well. And the descendants of Henry Ford still work with the company, is that right?
They do, both in our board as well as in the management team. The Ford family is here. They are still providing leadership, both in the strategic vision as well as other members of the family, which are in the board. And I think it really is actually exciting because you can be at events and the Fords can be there, and that's pretty cool. You can't get away from that.
Yeah, it must be pretty incredible to be part of a company with that much legacy.
It is, and it gives you a sense of it gives you a sense of the handoff as the generations have come through. It also gives you a sense of that they're looking out for the best interests of the company. So as an employee, I take a greater stake in it because I know it's important to the Ford family, and that makes me feel very proud to be a part of such an organization. So it's great.
There's a lot of change coming to the automotive industry right now, and I'm wondering for you, what is something that you're most excited about for the future of the automotive world?
As you said, there's a lot of change. There's a lot of disruption in the automotive industry. So new propulsion systems, new materials, new competitors, and the changes that go along with climate change and other very important issues of sustainability. But what that means for engineers is that's a lot of opportunities of things for us to get involved in and to be innovative and to provide problem-solving solutions and to really play a role in helping Ford and supporting Ford, as well as just the automotive industry in general, and keep it going. So it is exciting. It is a little scary in some ways, but I think engineers are well suited to address the many problems that are coming.
Thinking about the future of the automotive world, I know something that's on a lot of people's minds is electric vehicles. Do you have an idea of when electric vehicles might reach widespread adoption or eventually replace internal combustion engines?
I can't comment on when they would replace internal combustion engines. The reason is because I don't know. But I think widespread adoption is just around the corner. Every automaker that I can think of has at least one EV on the market or is soon to come to market. Hybrids are everywhere. And I drive a hybrid Escape. It's really, really nice. Great fuel efficiency. And I think that EVs will be very commonplace, sometime between now and 2030. In Dearborn, when you were here, you didn't get to come here, you're virtual. But had you been here, and I apologize for that, I wish you were, you would have seen there are Mach-E's everywhere. So it's becoming pretty commonplace.
Mm-hmm. George, what field do you think is a growing field right now that a young engineer, an aspiring engineer, should be looking into?
I think if you went online and you look for jobs that are available today, you'll see a lot of statistics and data analytics, a lot of work in e-motor design and battery design, and that's generally available. And then the other is material science and metallurgy. A lot of the challenges in batteries, a lot of the challenges in sustainability, whether it's polymers or metals, these are material science and metallurgical problems and physical science problems. And so that's where a lot of the solutions are going to come from. So there's really a lot of great opportunity there.
As a lot of young people are planning a career in engineering, they may be wondering about education level. What education level is appropriate for a career that I might want to pursue? And I certainly consider myself in this category. I'm about a year away from finishing my bachelor's degree at the time of this recording and considering maybe a master's degree. So for me and for everyone at home who might be wondering, who would you recommend pursue a master's degree and who might you recommend pursue a PhD?
Well, I think I don't want to bend anybody in groups. I'd say here's an approach I took, and maybe it works for others. When you're an undergraduate, try to go have 1 or 2 internships with a typical, engineering firm in your area, wherever you live, whether it's at the college or around the college or wherever your home is. Get a sense of that. And if you really like that, undergrad, get your bachelor's degree, go work in a field. That's great. If you feel like you don't know enough, or you want to dive deeper, you want to specialize in one topic, that's where a master's really does help it. It gives you sort of dip your toe into specialization. And if you, though, feel you want to narrow down and you want to go even further into research and advanced engineering, that's where a PhD comes in. If you want to be a person, and also if you want to teach, you want to be a professor, but you don't have to, because there's folks like me who are industrial PhDs. And I always have wanted to try to drive things as far as I can to understand them. And if you have that sort of sense about you, you don't have to have a PhD to do that, by the way. But if you work in a company or in an area of research, you might want to. And so that would be my advice. Go get an internship and get a sense of how far do you want to go and dive into specific topics. And then that'll help guide that.
And then I guess while we're on the topic of advice, do you have any other piece of advice, could be anything big, anything small, that you'd like to give to a young person, maybe middle school age, who might be considering a career in engineering?
Well, I think that, if you or your parents know an engineer, talk to them, ask to talk to them about their path to engineering, what they do, ask them if they find it fulfilling. One of the most important things is to make sure, or do your best to find a career that you have personal fulfillment. That's what leads to a good long career. You don't want to burn out. You don't want to hate it. And go online, research ABET accredited engineering schools. They're everywhere. They're in many cities and every state. So just find your local ones, or look up the one that you love most. Like many folks love MIT, where you're at. So they should definitely go and look at what it takes to get in there and prepare yourself for it. So visit the schools, meet professors, start taking, if you get a sense and you have a feel that you might want to be an engineer, please take as much math and science as you can in high school. And if at the end of high school or your junior year, you're kind of 50% that you want to be an engineer, I would say go for it. Because you don't, even if you get a degree in engineering, that doesn't mean you have to be an engineer. The degree is never wasted. You've proven to everyone that you can get through a challenging curriculum. You have learned the arts and sciences of problem solving, which is really what engineers are. And you've learned fundamentals, but you've really learned how to problem solve and how to dive in yourself and research and benchmark and figure out how to give a solution. And then you're well positioned if you want to go to business school and maybe do a startup or work in finance, or be an astronaut. Many engineers go into even law school, become patent attorneys, go to medical school, join the military, go to the FBI, whatever. You're never held back by getting a bachelor's degree in engineering. So I'm a huge fan. Of course I am, because I am one, but I really do think that everyone is well served by those degree programs. So.
All right, that was the last of the questions that I had for you today. But George, I want to say thank you from the bottom of my heart for taking the time to talk with us today. I know I've learned a lot, and I'm sure the Builder Dude 35 community has also learned a lot from your very insightful words. So really, thank you.
Well, thank you so much for having me. I really appreciate the invitation, and I hope your community likes what I had to say, and I encourage everyone, please look for engineering and keep doing engineering at home. So.
Thank you, George. Have a good one. Well, there you have it, everyone. That was George sharing his wisdom on pursuing a career in engineering and the future of the automotive industry. I certainly learned a lot during this interview, and I hope you learned a lot too. I had an absolute blast interviewing him, as well as working with his group this summer. So let me know in the comment section below what the most interesting thing that you learned from George today was. I'd love to hear your thoughts. Thank you, and I'll see you all in the next video. Later.